In this paper, we present a modeling approach to provide students with basic mastery of electrical circuitry using an augmented reality-based educational curriculum. AR, which superimposes virtual information to the real world, delivers a unique hands-on, minds-on approach to explore educational content. In our work, we first break down a subset of electrical circuitry into microskills, which are the smallest segmentation of knowledge that a student needs to know. Then we proceed to align the microskills to the AR technology. We will demonstrate how we leverage the medium of AR for educational applications. Session 1 workflow was composed of 5 parts: microskills, an interactive example, task 0, which was an assessment task, then microskills depending on the AR condition, and task 1. For task 1, students had to review the microskills. One group of students was assigned to partial AR, which only presented students with the microskills they were missing, and another was assigned to full AR, which presented students with all the microskills, without any emphasis on their knowledge gaps. Partial AR group had their knowledge space calculated from task 0, and thus they were only provided with the microskills that they were missing. These are the 10 microskills which students had to learn from. Students pressed the expandable tab to see all the microskills that were available. When students clicked on the play button at the bottom left, the narrator and AR animation instructed students on each microskill. Students only had one interactive example in each session. Here, students would try to mimic the process by following the AR step-by-step animation and narration. For session 1, we tested students with task 0 and task 1. The following video shows a student doing task 0, the assessment task. This student was initially provided with a description of the task and the spec sheet of the miscellaneous component, which the student needed to interpret to connect to the microcontroller. From the results of the Q matrix, students in the partial AR group would only study the microskills that they missed and move on to the next task. For the full AR group, students would have to explore from the list of all microskills without any emphasis on any microskill. Session 2 had the same workflow as Session 1, in which the knowledge space of each student was recalculated after each task, and this time they finished tasks 2 to 8. Here are the new tasks that students had to accomplish. This model, by providing feedback on deficient microskills, appropriately targets the AR learner to fill the knowledge gaps.